Good morning, everyone. My name is Simon Onilo. Welcome to today's lesson. Our topic for today is trigonometry, and our lesson objectives are to recall the formula for the sine rule, understand when and how to solve for unknown sides and angle in a non-right-angled triangle, then apply these rules to solve problems involving triangle. Now, pay attention to the words non-right angled triangles. Now we are familiar with finding the sides and angles of a right angled triangle using trigonometric ratios, SOHCAHTOA. SOHCAHTOA, where you have your sine theta to be opposite over hypotenuse, your cos theta is adjacent over hypotenuse, and your tan theta is opposite over adjacent. Now you can only do this when you are working with a right angle triangle. So how do you find the sides and angle of a non-right angled triangle? So to do this, we apply sine rule or cosine rule. So for today's lesson, we'll be exploring sine rule. Now, this is a non-right angled triangle, and the formula for the sine rule is this. All right. So A, small letter A over sine capital letter A equals small letter B over sine capital letter B equals to small letter C over sine capital letter C. The small letter A there serves as represents the sides of the triangle, while the capital letter A is the angle. So for this is angle A, this is angle B, capital letter, this is angle C. Now the side opposite the angle is the small b. The side opposite the angle is small a, and the side opposite this angle is your small c. Now sine rule can also be written like this. You just invert the positions. Now, when do we use sine rule? Okay. Sine rule is used for cases in which cosine rule cannot be applied. It is used to find an angle, an unknown side, when we are given two angles and a side. So when you're given two angles and one side, you can use a sine rule. Also, you can use it to find an unknown angle when you have two sides and an angle that is not included. What I mean by not included is, now, they said two sides. For instance, they gave us this side and they gave us that side. This is the angle included. So when I mean angle included, I mean the one that the two sides enclose. Also, let me show you another. If we have this side, say we have A and we have B. That means this angle C is an included angle if it is given. But for us to use sine rule, it's when two sides and an angle that is not included is given. Okay, now let's solve. Find the size of x. Looking at this, we have two angles and we have one side. So we can find this other side. Note that sine rule connects a side and the opposite angle. So like this and like this. So when I cross multiply here, I have x sine 40 equals to 8 sine 30. So divide both sides by sine 40, tap my calculator, and I have this answer. So this side, 6.22 centimeter. Let's look at another question. Find the size of the angle X. So here, two sides are given and an angle that is not included. So we use sine rule and know that the sine rule connects a side and the angle opposite. That was multiplying, solving for X. This time around, we are looking for an angle. So we find the sine inverse of this value when you punch it in your calculator. You get your answer for X. Now let's look at an application question. The angle of elevation of the top of a building measured from point A is 25 degrees. At point D, which is 15 meters closer to the building, the angle of elevation is 35 degrees. Calculate the height of the building. So we are told that, okay, I'll hide my page. Okay, so I like to draw the ground first. So this is my ground floor. Now, from this point A, we are told that the angle of elevation to the top of a building is 25 degrees to the top of a building. So this is the top of my building, and it is 25 degrees. So let's say this is the height of the building, and this is the bottom. Now, the question went on further to say that at point D, which is 15, so somewhere around here, which is D, and it is 15 meters closer to the building. That's the building. The angle of elevation is 35 degrees. Let me redraw that. Okay. So we are told that the angle of elevation from that point is 35 degrees. Now the question says calculate the height. This is the height of the building. Now, we see a right angle triangle in here. There is a right angle triangle in here. Let's extract the right angle triangle. So if this is 35 degrees, and this is X. Now, if we had the hypotenuse or we had the adjacent, we would have been able to find this X easy using our trigonometric ratios. But then this is an incomplete. It has incomplete information. But looking at what we have here, we see a triangle here. Now let's extract the triangle. Okay, pardon this line. So here is 25 degrees. Here is 15 centimeter. Now, looking at this, we have this angle on a straight line adds up to 180 degrees. So that makes this place 145 degrees. So here is 145 degrees, 145 degrees. Good. And if we have 145 degrees here, remember sum of angle in a triangle is 180 degrees. So the 145 plus 25 is 170, 180 minus 170 is 10. So here is 10 degrees. And we actually want this side. So this is 1. And remember sine rule, the side connects the opposite angle. So these and these are opposite angles. So we have 15. So we have 15 over sine 10 equal to these and these are connecting y over sine 25. So when we cross multiply here, we'll have y equal to y sine 10 equal to 15 sine 25. So when we divide both sides by sine 10 degrees, we'll have y equals to, when you punch that into your calculator, 15 sine 25 divided by sine 10. So y should be to the one decimal place, 36.5 centimeter. So now we have 36.5 centimeter here. So we can easily use trigonometric ratio to find x. So for the second part, we have our angle to be 35 degrees. We have opposites as x. Then we have our hypotenuse to be 36.5. So we know we are using sine from so. So sine 35 degrees equals to opposite over hypotenuse. So when I cross multiply, I have it that x equal to 36.5 times sine 35, which is 20.9 centimeter. So this means that the height of the building is 20.9 centimeter. So that's how you apply sine rule. And in our next class, we'll look at cosine rule. Thank you. Bye for now.